A sidewalk is built around two sides of a building. What is the area of the sidewalk? Note, the diagram is not to scale. That means not to scale just means that the picture may seem like it's smaller or larger than the dimensions. All right, so we want to find out what is the area of the sidewalk. So we want to figure out how much space this sidewalk is taking up. So here we have the building. So this is the building. And the sidewalk is going to be on the outside of the building. So the blue is going to be the sidewalk. And we want to figure out how much area is taken up by the blue. So if we see the building and the sidewalk is equivalent to a rectangle with the dimensions of 120 meters for the base and 75 for the height, 75 meters. We can say that the area of that, well, we will have to use a formula. So we have to use the formula for a rectangle, which is base times height. The base is 120 meters and the height is 75 meters. So if we multiply 120 by 75, we end up with 9,000 meters times meters, meters times meters is meters squared. So the building and the sidewalk is 9,000 meters squared. Now we can easily find the area of the sidewalk, which is, or the building, not the sidewalk. We want to find the sidewalk, which is unknown. This is an irregular polygon, so we can decompose it or we can subtract. So this is the sidewalk, and then we have the building right here, which is the shape of a rectangle. So if we look here, the dimensions of the building is 118 meters. And the height of the building is from here to here, which is 73 meters. And since this is a rectangle, we use the formula base times height to figure out how many square units is inside of this figure. So if we substitute 118 meters for the base and 73 meters for the height, we have to multiply 118 times 73, and we end up with 8,614 meters squared. And then if we know the building plus the sidewalk is equivalent to the area of the building and the sidewalk, because that's what the larger rectangle is, we can find the value of the sidewalk, the area of the sidewalk, by subtracting, by getting the variable on one side of the equal sign by itself. So we have to move 8,614 meters squared minus 8,614 meters squared, and then we'll have the area of the sidewalk. This will cancel out. X is equivalent to 386 meters squared, and that is our answer. So we can type that answer in. Now another way to do it is to decompose. So we have our irregular shape. Whenever you have you want to find the area of irregular shape, you can decompose it. So we can decompose it right here, or you can decompose it here. I'm going to decompose it right here. So now I have two rectangles. But I need to find the area of both of those rectangles and add it together, and that'll be the area of the sidewalk. How much space is the sidewalk taking up? So if I look here, I have a little segment. I have a little segment right here. That's the difference. So if this is 100, from here to here is 120, and from here to here is 118. This must be 2 meters, right? Because 118 plus 2 meters is equivalent to 120. So I can say the base of this is going to be 2 meters. And then I know the height is parallel to this right here. So the height is going to be 75 meters for this little part. And then I need to find how much space this is taking up, the length and the width, to find the area. So I'm going to come over here, and I know that the length is going to be all the way across. So it's 120. Oh, wait. I decomposed this part off. So it's actually going to be 118 meters. 118 plus 2 meters is 120. So I have this right here. So I'm trying to find the area of this. I need to find the base and the height for this region. that's going to be equivalent to this right here. So I have 118 for the base because it's parallel to the building. And then I have this little portion right here. So if this to here is 75 and from here to here is 73, I can find this value by subtracting 75 minus 73. So this must be equivalent to 2 meters because 73 plus 2 meters is equivalent to 75. So this plus this must be equivalent to this and 75 because they're parallel. So I can say that this is equivalent to 2 meters. So I can use my formula base times height plus base times height because I have two rectangles. And then I can substitute 75 meters here times 2 meters. 75 times 2 is equivalent to 150 meters squared, because meters times meters is meters squared. And now I need to find the area of this other portion. And when I add them together, I can see how much space they are taking up together. So I'm going to substitute my base and my height in. So 118 meters times 2 meters. So I have 118 times 2, and that's equivalent to 236 meters squared. And then I need to add them together to see how much space they take up together. So 236 plus 150. And I end up with 386 meters squared. Meters plus meters, you have to combine like terms, adding and subtracting. So these are like terms, meter squared and meter squared, so we can add them. Notice we got the same exact answer, but we use two different methods. So I'm going to go ahead and put the answer in. So the answer to this, either way, is 386. You can use whichever method you want to use. They both are correct. And we're going to move on to the next question. This one is fairly easy. So the polygon is made up of a rectangle and a triangle. The area of the rectangle is 54 meters squared. Find the area of the polygon, use pencil and paper. So we know the area of the rectangle. This is the rectangle right here. And it says the area of this is 54 meters squared. So if we know the formula for a rectangle is area is equivalent to base times height. We know that the base is 6 meters. We don't know what the height is, so we can keep a variable for the height. But we know the area is 54 meters squared. Meters times meters. If we want to find out what x is, which is the height, we can divide both sides by 6. Get the 6 meters to get the variable on one side by itself. And then we can say that x is equivalent to 9 meters. Now 54 meters squared, so for our units we have meters times meters, that's equivalent to meters squared for the numerator. And then in the denominator we just have meters. So 1 meter is going to cancel out with 1 meter, and we left with our units of a meter. So that's how we end up with 9 meters. So what does this mean? X is equivalent to 9 meters. What does the x represent? X represents the height, because that's what we substituted, the variable that we substituted in for the height. So we can say that x is equivalent to 9. Now it says we want to find the area of the polygon. Find the area of the polygon if the area of the rectangle is 54. So now if we look here, we know that the height is 9 meters, the base is 6 meters. So we need to find the area of this triangle and add it to 54. So if we decompose it, we need the area of the triangle plus the area of the rectangle, which we already know the area of the rectangle is 54 meters squared. And then we need to find the area of the triangle. So to find the area of the triangle, we need to use our formula for a triangle. A triangle is half of a rectangle, so I'm going to use 1/2 times the base times the height. And since I know my base is 6, because it says 6 right here, and I know my height is 9, I can find the area. So half of 6 is 3 times 9 is 36 meters squared. And then I can add 54 plus 36 to find the answer to that, which is 90. 3 times 9 is 27. Oh, here we go. 3 times 9 is, oh, I didn't even finish writing it, 27 meters squared. So we have the area of the triangle is 27 meters squared. And we have to add 54 plus 27, which is 81 meters squared. So the area of this triangle is 27 meters squared. And since these both have the same base, and the same height, so this is 6 meters and this is 9 meters. They both have the same base and the same height. And we know the area of a triangle is half the area of a rectangle. So if we know that the area of the rectangle is 54 meters squared, we can divide it by 2 to get the area of the triangle. 54 divided by 2 is 27. So we know that the area of the triangle has to be 27 because the base and the height are exactly the same on the triangle and the rectangle. So we have our final answer, which is 81 meters squared and not 90. So 81 meters squared. And we're going to go to the last question. So this question is fairly easy. We just want to figure out how much will it cost to mow the lawn. So we know that each square foot is going to cost 1 cent per square foot. So we can use that as a conversion factor. But first we need to figure out, okay, how much feet are we going to mow? So we're mowing everything except for the sandbox. So we can find the area of the sandbox and the line, which is 49 by 39. So we can find, you can use base times height, that's both of them because the sandbox is included in the base and the height of the rectangle. So we have 49 times 39 feet squared. So we have 49 times 39, and that's equivalent to 1,911 feet squared. So that's the area of both of them, but we're not mowing the sandbox. So since the sandbox is the shape of a square, we know a square has all equal sides, so the area of this is going to be area equals S squared. We're going to use that formula. The side length is 4 squared. 4 squared is 4 times 4. So the area of the sandbox is 16 feet squared. So I need to subtract the area of the sandbox. So I'm going to subtract 16 feet squared from this, from the area of both of them together. And then I end up with the area of 1,895 feet squared. And then I need to, if it costs 1 cent per square foot, I have 1,800 square foot. So I need to multiply, right? Or I'm going to use it as a conversion factor. So I have 1,895 feet squared. And I'm going to use my 1 cent per square foot as a conversion factor, or I may need 1 foot per, I don't know which one I'm going to need. But I see here that I'm starting with feet in the numerator, so I know I need to put feet in the denominator, so I'm going to use this conversion factor. So feet, square foot. And then this tells me that I need to multiply to figure out how much I'm going to spend. So I need to multiply the square foot by 1 cent, and then I end up with $18.95. So that's how much it's going to cost to mow this lawn. So you have to find the area, and then you have to convert that to the cost. And that's how you answer this question.